Thank you for joining the Judaism Demystified podcast. So I have on for the first time two guests at the same time, which is Rabbi Elie Feder and Rabbi Aaron Zimmer. It's an absolute pleasure. I've had Rabbi Feder on before. We did the Gematria episode with Bensi. And tonight, my special guest co-host is Zeb Godkin, who was on previously with Dr. Brian Keating. So we felt this would be a great opportunity to have a similar conversation. So first, before we start, if you can both tell us about yourselves and your background.
Sure. It's a pleasure to be here. Thank you. Thanks for having us.
Our pleasure.
So let me tell you a little bit about myself. I come from a background, from a home which has a strong commitment to Torah and a strong commitment to, I guess you call it derech eretz, to making a living, towards knowledge of the world, science, philosophy, psychology. My father is a rabbi, but he's also a lawyer. He's in business. My grandfather is a rabbi, Ismicha from the Rav, and also he was a chemist. So again, I have a strong valuation for both setting up a life built around Torah, but also a life which pursues Chachmas Hashem in a broader sense of the term. And I guess as a kid, back from the time I was a kid, I was always a math guy. I was like that kid in class who was good in math. So that was just me. And it was like a thing, it was a natural thing. I was always interested in math, good in math. I was always interested in sciences in general, but specifically math was my thing. So I guess as I went to college, I learned in yeshiva. So I decided, again, I was interested in Torah. I wanted to teach Torah. So really attracted me a lot. At the same time, I also wanted to make a living, and I also valued a career, valued knowledge in a more broad sense. So I ended up going to graduate school. I got a PhD in math. And now currently I'm a rebbe and I'm a math professor. And this kind of like a balance. It's always, again, I feel like my intellectual involvement is in Talmud Torah, but also in math. I read the math research. I publish papers in a field called graph theory. And that's kind of, I'm very involved also in, besides math, also studying physics and science and psychology, philosophy, that type of thing.
And Rabbi Zimmer?
Okay, so that was Elie. My name is Aaron Zimmer. Thanks for having us on. We appreciate it.
Pleasure.
I went to I got a degree in college in physics, and while I was getting my rabbinical ordination, I was raised in a modern Orthodox community, so I've always had, in a certain sense, one foot in the modern world, science and secular studies, and one foot in religious and Judaism and Torah. And after finishing college, I wasn't quite sure what to do. I decided not to go to any graduate program. I had a lot of other interests that I wanted to do besides just focusing on physics. So I ended up trading commodities, commodity futures like oil and gas and cotton, sugar, things like that. And after 11 years, I was fortunate enough to be able to retire. And now I make this podcast, Physics to God, and basically I have the time to really engage in studying Torah and Gemara. I learned with Elie. We've been learning for over 20 years now, having other chavrusas, and also being able to study, different areas of interest to me, physics, philosophy, psychology, amongst other different areas.
Amazing. And you guys, how did you get involved with fine tuning?
Okay, so fine tuning, that's what our podcast is, at least starts about, the argument from fine tuning, which I'm sure we'll get into a little bit more what exactly that argument is, just in a most basic background. It's an argument that seems to indicate from the laws of physics that the universe must have an intelligent cause. And basically, it started out, it was 15, 20 years ago. I came across this book by Lee Smolin called The Life of the Cosmos, which talks about these numbers that are, or quantities, maybe is the better way to say it, quantities that are part of the laws of nature. So for example, the simplest one I think to convey to people is an electron. Everybody's heard about an electron. So electron has a certain mass, how big an electron is, how much it would weigh. And that's a specific number. It's a specific quantity. It could have been bigger, it could have been smaller. It's something that's almost like fundamental. It's built into nature. Every single electron has the same mass. And I was reading in this book how if this mass was different of the electron, and plus other quantities in nature, how if this mass was different, you wouldn't have atoms. Atoms wouldn't exist, and you wouldn't have molecules or stars or planets. And then Lee Smolin went through a bunch of different ones of these constants, these quantities. And he was discussing how like these numbers are so essential. They have to be exactly or very close to the value that they have in order for the universe to really work, to be the wonderful universe that we know about. And I was struck by this is incredible. Like how exactly, where did these numbers come from? And so was he. And he was a physicist. He didn't believe in God. And he had proposed his own theory. He mentioned some theories scientists had, and they weren't very good. The alternative theories. And I was pretty kind of shocked. I came to Ellie, like, Ellie, this is unbelievable. This is like the best argument I've ever heard for the existence of God. I mean, he wasn't making, Lee Smolin wasn't making that argument, but I was blown away. It was just better than anything I'd ever seen before. And I've been looking because, it's, again, I was modern Orthodox. So in a sense, there's always this dichotomy you have between religion and the secular world, the modern world. And you're always trying to, at least for me, I was always trying to integrate those two. I didn't want to have a dichotomized existence. Like the Rambam introduces in the Moreh that he doesn't want, the Rambam says he writes the Moreh because he doesn't want a person to have to choose between their intellect or their religion. They should be able to harmonize the two. And I kind of felt that in the modern world, that it was almost you're being asked to do that choose either to have, put your intellect on the side and have faith and believe, or to, or embrace your mind. And then you kind of can't be religious. It wasn't really presented very clearly to me. Judaism in a really compelling way that integrated my intellect. And here I saw something, at least for the foundation of religion, for God, which was the basis of it all, that really seemed a compelling argument. So that really struck me. I got together a few of my friends, and I gave like a little lecture to them. But I mean, I kind of left it at that. What exactly are you going to really do with this? What was I going to do with it at that point in time? And I kind of left it at that after the little lecture, and it was and that was where we stopped for that temporarily.
But for us, especially adding on to Aaron's point, is that in this world, in the modern world, there's many atheists, scientists who like to say God is outdated. We don't need God anymore. The whole thing is make-believe. And that's something which we hear. I'm sure a lot of your listeners have heard it. And I feel like in a certain sense, being religious is somehow looked down upon by the scientists of the world. And specifically, I think when it comes to, I guess, biology is one of those areas, because again, for many, many, many years, it's always been this idea of life, the complexity of life and design, and that shows that there's a God. And I guess nowadays, with the theory of evolution and Dawkins and all these different atheists, they kind of have this sense that no, you don't need intelligence to explain life. Rather, the theory of evolution explains it, and therefore there's no need for a designer. And that whole argument, they feel that's all out, ancient types of things. And there's a lot of pushback. There's a big discussion whether the argument from biology still holds up or doesn't hold up. And there are two sides to the story. And it's, one might be convinced, one may not be convinced. It's hard to push that case. And I remember when Aaron had told me about this book that he was reading, and he saw this argument from physics, it's like totally it hit me. I was like, wow, this is unbelievable. This is a totally different type of an argument. Because see, when you're dealing with biology is like emergent from a long chain of chemistry and physics. And it's not a primary phenomenon in the universe. It really is results from other factors. And that's the question is, how did biology get started? Is it, again, the claim is it's from a long chain of life, and either simpler and simpler, and then how did DNA get started and all the different building blocks of the DNA. But that's a question. Does the theory of evolution, does what they call the multi-planet solution, do these things really explain the emergence of life, or do they not? And there's big debates. But this argument or this discovery of what we're going to talk more about, a fine-tuning of these numbers, the laws of physics are the most fundamental foundation of our universe. And our universe these are like the building blocks of our universe. They didn't evolve. As far as we know, these numbers, which Aaron is talking about, they call them constants, the constants of nature. And they're called constants because as far as we could tell, every measurement that scientists have ever made of them, these numbers are constant. The mass of an electron is always that exact same number, every single electron throughout the entire history of the universe. And the laws of nature, they're fixed. Laws of gravity, laws of electromagnetism, the laws of, as far as we know, there's no evolution of the laws of physics. These are the fixed, built-in laws in our universe. And therefore, the types of critiques, arguments, which people have on the argument for design from biology simply aren't applicable to when it comes to physics. These are like baked into the very fabric of our universe. And when we discovered this based, again, on Smolin's book, it was like, wow, this is unbelievable. This is something different. And it kind of got us interested in being able to, I guess, to show it, to share with other people.
I wanted to ask about the 4 cosmological constants. I have read that there's research that technically you could create a universe, I don't know about with life, if you altered them, but it would have to be across universal values. Is there anything you would have to say about that?
What do you mean? Can you explain a little bit more?
So they say that these 4 numbers, the numbers that you're talking about, they said that you could tinker with them, but I've read that you would have to change all of the equations, like across the numbers would all have to change across universal value. So it's not like, yes, if you tinkered with one, the whole thing would fall apart. But if you, I guess, adjust for all of them, like the numbers could be different in theory. And that's what I've heard. I don't know. What do you think of that?
Right. Yeah. In theory, there's. It's funny. It's funny that you're talking about like just 6 numbers, maybe from Martin Rees's his very popular book that came out a little over 20 years ago, where he talks about these numbers. So there's, he had 6 numbers in that book. Maybe you're thinking about that when you're saying the 4 numbers, but say 25 of these constants. So it's true. If you move, let's say one of them, you don't have atoms, things like that. But in theory, if you move a bunch of different ones, maybe you'll find a different combination that would work. And that's true. That's possible. The point ultimately becomes, though, that almost all different combinations don't work. So even if there's out of the space of a trillion different combinations, even if the one we have works, maybe there's 10 other ones. Just a theoretical. It's really have to kind of make like a space of different possibilities. But in the end of the day, it ends up not making a difference. The fact that there might be other possible combinations that work, so long as the vast majority of them don't work, it becomes unreasonable to say that just assuming there's only one universe, that we just got lucky by chance and it happened to be right. It ends up not really mattering the fact that there's a few other possibilities that might allow for planets and stars and galaxies and life, as long as the vast majority don't work. But that's correct. Like there are definitely people who argue something like that, but it doesn't ultimately affect the argument in any qualitative way.
So going back to how you guys started, why did you decide to make this more public? Like what happened that you guys obviously had the blog shiur. So what made you guys decide that this is what you want to do?
Okay, that's it's funny actually that it had to do with that book by Martin Rees, just six numbers. It's funny. I came across that a few years later, and that was really when I was first exposed to the alternative scientific theory, the multiverse. So Lee Smolin mentioned it in the book, but he discarded it as like kind of ridiculous. He didn't like it then, and he doesn't like it now. But Martin Rees was proposing it, and it seemed like a lot of scientists were saying it. And the multiverse is this belief that there really are this infinite number of parallel universes that we never can observe. And in each one of these universes, these constants are different. They have different values. And it's like if you have an infinite number of universes with different combinations for these numbers, then by chance, of course, you're going to get one universe, which happens to have the constants the way we have. Now, it's true, 99.9%, like I was saying before, the overwhelming number of these universes have no planets or stars or atoms or life or anything like that in them. But you don't see those universes because you can only observe a universe which has life in it. So that's what the multiverse says. Of course, you happen to be in the one universe which has life because you can't observe. No intelligent observer could ever exist in the universe without these things. But they really believe there are these infinite number of universes, the vast majority of parallel universes that are completely unobservable that exist that nobody can see. And they were proposing this as, like, scientists were saying this as a good possibility for them to explain the value of these constants. And once I realized, you have to think it through. What exactly are the problems with this theory? Right away, it just doesn't seem, it struck me as completely outside the normal scientific method of analysis, of where they make, predictions and observations compared to experiment. All of a sudden here, scientists were positing this infinite number of unobservable universes. It sounded like it was science fiction. It just didn't seem right. You had to analyze and look into it. It's a little bit more of a sturdy theory than initially I thought. I thought it was really crazy when I first heard it. Now I think it's just a bad theory, not completely crazy, but just not good. But when I just first saw it, I'm like, wow, this is it. This is the way you can bring this public, because it's very hard to convince people that there is a good argument here, because it's physics, and you have to explain. Even if you explain it to them, what these constants are and why they are fine-tuned. If they changed a little bit, you go through the whole thing. If people always had this certain doubt of, like, okay, I don't know, it's physics. What does it really mean? What would scientists say if they? I'm sure because scientists don't believe in God, or a lot of them don't. So how would they explain this? But now all of a sudden, I had this theory of the multiverse. I could show people, this is what scientists are saying, and you can see for yourself that they're not saying a regular scientific theory like evolution, natural selection, like in biology. That's a real scientific theory. Now, again, do you want to say it explains everything in life? It's a different question, okay? But it's a real scientific theory. There's real evidence behind it. There are fossils in biology. There's evidence, there's data that it's based upon. But in physics, there's no fossils in physics. There's no evidence for these infinite numbers of alternate universes, or it's certainly very weak at best. And there's no predictions, and there's no observations that confirm this experiment. Completely different type of thing. I realized that this is the way to show people articles or videos about the multiverse. And that's going to really convince people that there's a real good, strong argument over here for the fine tuning in physics.
Right. So at the time when we started seeing this, we started hearing scientists started putting out videos about the multiverse, and it was kind of catching, people started picking up on it. Nowadays, I think the word multiverse is, hear it from all the movies and like Marvel and all that. But this is like maybe 10 years ago, where it started becoming more and more accepted by scientists. And we saw it as an opportunity to use the prevalence of this belief to show people there's a real problem. Fine tuning is a real problem. And the alternate solution, like we're going to argue that it points to God, but the alternate solution is infinitely many universes. And if scientists are saying that, something's up. There's a real problem here. You can't just ignore the fine tuning. And at the time when Aaron and I, we had a lot of conversations about this. So at the time we were currently, as you guys mentioned, the blogosphere. So this was in this time when blogs were big. I don't know if they're so big anymore, but so we had a blog which we were using to teach Torah, to teach a Brisker Derech, and we called it blogosphere. And this is right what we were writing these pieces of Torah. And then we says, you know what? We already have an audience. We have people who are teaching Torah too, and people who are interested. Why don't we take this line of reasoning, which is, again, a class Aaron gave to a few guys, and they were interested in it. Why don't we try to actually write it out and spell out the argument? And sure enough, we decided it was one summer, and we wrote like 20. I think you mentioned that you guys read it a little bit, but we wrote like maybe 20 blog posts, and there was a lively conversation. We had a large group of people who were involved. Most people who are religious, but then we had like one or two atheists who were on. It became like a lively discussion, back, forth. And we really, it helped us develop the argument, help us spell it out. We got pushback, we got questions, and it was very, it was a nice experience to be able to really go through and write out and put out the argument in a more concrete form, which was, again, it was initially just like an intuitive argument, but then we actually made it more rigorous and spelled out the different steps.
So, Rabbi Zimmer, I'm actually interested because you mentioned that at first it was ridiculous and then it was just bad. So there's a progress there. Why did it become better? Just because
you know why? Because like when you first hear it, you think that scientists are saying that if you have an infinite number of universes where everything happens, then you're going to have one universe where anything you want happens. That you get the constants exactly right. It's actually a really subtle point here, and that's what I originally thought. And that just becomes like really crazy because then you could literally explain everything by that theory. Because there is a multiverse. I mean, scientists say this. There's a multiverse where people get out of their graves and wake up, and you have Tchias Mesim, and there's scientists talk about that there's a multiverse where that occurs. It's crazy. Tchias Mesim occurs. There's a multiverse where the sea splits. There's a multiverse where pink elephants walk on the street because you have to appreciate the idea of infinity. If you really have an infinite number of universes, then anything that's not in violation of the laws of nature, and almost nothing is a real violation of the laws of nature once you take into account quantum mechanics and probabilities that anything possible can really happen. These things don't really violate the laws of nature intrinsically. They're just statistically improbable. But an infinite number of tries, everything happens. That's really a crazy theory, completely crazy. Scientists, in fact, aren't saying that. They're saying something a little more subtle. And this is ultimately the undoing of multiverse. And it's a subtle point where we're going to discuss it. It has to be developed, but they actually hold that in this infinite number of universes, the most typical universe that has intelligent observers looks like our universe. Okay, so that's, again, it's a subtle point. We're going to make a separate on Physics to God, the podcast. We're going to make a separate mini series about the multiverse, which you have to explain this point that scientists do maintain and they have to prove, which ends up becoming the whole undoing of multiverse. They have to prove that, or prove, or whatever. They have to establish in some compelling way why our universe is the typical or most common universe that has intelligent observers. So that's like a subtle thing. And because of that requirement, multiverse is not completely crazy, but because of that requirement, that ultimately becomes their undoing. How they tried to solve that problem.
Right. Well, one thing I've always wondered with the multiverse theory and my discussions with people about is how much of it is just a creative, not creative, but like an innovative way to explain the seeming fine tuning, like have an alternative, and how much of it is based on some solid like mathematical discoveries. And I mean, I know it's still theory, but cosmic inflation has really taken over in the world of physics. It's kind of most physicists, with some exceptions, believe that is what got everything started. So like how much of it is just like an alternative explanation to, you don't like fine tuning, so we'll make this, and how much of it is really based on the principles? They think it's a natural byproduct. Maybe the multiverse is a natural byproduct of cosmic inflation. What are your thoughts on that?
I think it's a combination of those two things and plus one more. So one is, it's called eternal inflation. Also a little bit of a complicated topic, but when they try to model the early universe, like you're mentioning, there is this theory of inflation that the universe expanded really rapidly. And basically the simplest ways to model that, if you don't want to fine tune that, because they don't like fine tuning, scientists, so they don't want to fine tune that, the simplest way to model it leads to this growth of other universes in this, bubble universes, they call it, and eternal inflation. You get these infinite number of universes. And that just comes out of their natural theory trying to model inflation. Again, some scientists who hate, there are real scientists who hate the multiverse because they see it as undermining science, which it really does. And they said, therefore, so either model inflation in a different way where it's, maybe more fine tuned, but you only have one universe. That is, after all, the job of science to explain our one universe. The job is not to explain universes we don't see. The job is to explain the one universe we do see. Or they say, inflation is not a good theory, but, explain it a different way. But scientists who do like the theory of inflation, and that is in the mainstream of science, it does seem to naturally lead to all these other universes. Second of all, they had this theory called string theory. And string theory, it was originally intended to explain our one universe. And eventually it became known that string theory explains an incredible number of possible universes, 10 to the 500. And scientists are always looking for a unique explanation of our universe. That's what science has always been after. Why is our universe the way it is and not some other way? And because they had this theory of string theory that led to this description of all these other possible universes, they said, hey, if there really are all these other universes from eternal inflation and string theory, maybe it's not such a big deal, that it's not a failure of string theory that doesn't explain our one universe and explains all these other possible universes. Maybe they really exist. And then you have the fine-tuning of the constants and everything becomes wonderful. You package all those three things together. You explain fine-tuning. String theory is no longer failure because the universes exist, eternal inflation, and you get the multiverse and a synergy of all these different things met together. And that's really why the popularity of multiverse really rose, because it kind of put together eternal inflation, string theory, and fine-tuning of the constants.
So really, the whole concept that really always bothered me was that, it seems like it's just a, moving of the goalposts, because, with the Big Bang Theory, it introduced the idea that, there is a beginning. And it seems as if this is what that is a reaction to, but it's an unfalsifiable argument. You're saying something that cannot be measured or proved. So like it's almost just like it seems as if like the scientists are just uncomfortable with a beginning. Is that a correct assessment in your eyes?
The scientists are definitely uncomfortable with the idea of a beginning. Albert Einstein, he what he called the greatest blunder in his life was introducing this term, the cosmological constant. And it's ironic. It comes up in the whole fine-tuning. Cosmological constant in 1998 was the discovery of it's the most fine-tuned constant that we have. But it actually was really introduced by Einstein, a completely different framework to explain why our universe, according to, I don't want to get too technical, but when Einstein first discovered general relativity, it led to the idea that the universe could be expanding. That was the natural interpretation of general relativity. The problem is, if our universe is expanding, it seems to imply that in the past it was smaller and eventually it has a beginning. And Einstein he didn't like the philosophical implications of a universe with a beginning, because what happens before that beginning? It seems to imply a creator. And Einstein didn't want to say that. It seemed unscientific to him. So he posited this cosmological constant, which was this highly fine-tuned thing in his theory. It's really fine-tuned to be used a little bit equivocally by me now. But he did that in order to make like this eternal universe, a steady state universe. And then when Hubble discovered that the universe was in fact expanding, that the galaxies were receding from us, Einstein changed, he said, forget the cosmological constant. I was wrong. It was the greatest blunder of my life. I shouldn't have gone away from the natural interpretation of general relativity, which implies the universe has a beginning, a Big Bang essentially, in order to avoid that philosophical implication. And that idea of scientists not wanting the philosophical implication of a God who either created the universe in the Big Bang, that's again not an argument from the Big Bang, or fine-tune the constants, design the laws of nature, all these different things, that's definitely there. Scientists are loath to admit into their philosophical framework the idea of an intelligent creator, because and I don't really want to speculate why. Maybe Ellie, maybe you want to explain why. Go ahead.
Yeah, so I'll be a speculator, but but I think I think most scientists, as a lot of people know, they've encountered religious people who have this idea of God, and it's not very worked out, and it's kind of sounds like magic, sounds like make-believe. And it's like the scientists know that they know irrational religionists who just, you're not solving anything by saying God. And okay, you just wave your hands and say God and pretend all the problems go away. And because I think people have been exposed to, unsophisticated versions of God, to Avodah Zarah, to just different ideas of God, which don't really explain anything, Scientists aren't just going to say, "Oh yeah, God," you say God, now you solve all the problems. They just know that that's not. It doesn't talk to them. They don't have a sophisticated idea of God, and
They reject the same God that we reject.
yes, exactly. We reject. I know that's like when we read these books by like Dawkins or whatever. It's like in a certain sense, there's so much animosity against God, but yeah, I reject that God also. And the ideas about God they're attacking that if only they knew about Yichud Hashem, if only they knew the Torah's idea of God. Maybe that's part of our argument, and part of what we're going to do in our podcast is that we need to show that the idea of God is cogent. We have to formulate it and show, and this is what we're going to show, is that the argument actually leads to a good, clear, cogent, rational formulation about how to think about God and how to answer the questions which scientists ask about God. I think that's part of the idea is because they don't have exposure to such a thing, they don't have any sophisticated view of religion. Their just view of religion is based upon what they learned as kids, and they reject it as kids, and their next door neighbor, who's kind of not really rational, has this idea. So God isn't an option. And because God isn't an option to them, so now when they see these things, they say, well, it must be a multiverse, because at least multiverse is scientific in some sense, and you could do the math and you could do equations, and that's like a better version of God for them than to have the things with their religious friends maintain. So in order for our argument to be sound and to actually lead to God, we have to show how God isn't subject to the same questions. Like if we'll say, well, who designed the universe? We'll say, oh, it leads to an intelligent designer. So they say, well, who designed the designer? Who fine-tuned the fine-tuner? And all these questions show that you're not really solving anything. And therefore, for our argument to stand up, we really have to do that. And we plan on doing that.
But it's interesting because who designed the designer, the multiverse is an even greater leap than God.
Yes.
So
so that's part of what we have to, that's part of what we have to make rigorous and to show. Again, it sounds that way. And this was our intuition when we started, when we did the blog. And it sounds that way. It sounds like, do you rather believe in infinitely many universes where everything possible happens, or one God who created our one universe? So there's an intuitive argument that way. But at the same time, to really be convinced by it, we have to go into the nitty-gritty of multiverse and see their supports and see the problems and see something which we're going to get into called the measure problem and see why it really fails in its claims. And then we also have to show, we could just say, hey, God is less of a jump, but we have to answer the questions. Otherwise, ultimately, you're just left without any good theory. You could say, okay, God isn't a good theory, multiverse isn't a good theory, and we just say, okay, we have a mystery, we don't really know. So that's our argument, is that, no, it does point to God. Multiverse doesn't really work out. It doesn't explain, doesn't meet the claims which it suggests that it does. And God actually is a good theory. And it actually leads directly to the idea of Yichud Hashem, which is formulated by, let's say, the Rambam and the Rishonim. And it actually is a cogent theory, which is directly pointed to by this argument.
And just to strengthen what you just said, I mean, I'm novice, when it comes to science. I love science, but I'm obviously not an expert like you guys. But I was watching the famous atheist Christopher Hitchens and Richard Dawkins and Hitchens. There's a video of him just admitting that the fine-tuning argument is not something you could just, throw away like it's some trivial thing. He's like, you got to really wrap your head around that. That's a tough one. The other one is that Dawkins admits that DNA, which interestingly his quote-unquote rebbe, Anthony Flew, became a theist or deist in his late in life because he saw the complexity in DNA, and he was like, there's clearly evidence of a signature. So Dawkins admits that, yes, there's this signature and there's clearly some type of intelligent design, but it can't be God. It has to be, maybe it's a higher intelligence, like an alien race, which to me is just like, okay, then you can also start that again. Who created that alien race?
Right. I mean,
Right.
I think Penrose or certain other people, even people who do go by the multiverse, they don't like. I heard some of them say on record, like the idea that just can explain the fine tuning. Like they'll say, I just don't like it. Like they don't like that idea that it explains everything. But
I just want to, before we move on,
Penrose-
I just want to address one point that you mentioned about the DNA. So the issue with DNA is the argument is good. The only problem is that they have what they call the multi-planet solution. And Dawkins talks about this in his book, The Blind Watchmaker, that they want to say, look, there are many, many, many planets which we observe, which are potentially hospitable to life. And therefore, they say, even if it's very, 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 very unlikely that DNA would emerge by chance, given enough planets and enough time, maybe we could just happen to get lucky once and we could just get DNA to emerge by chance. And these planets are planets which we've observed. And the difference between that and physics is that in physics, there's no observation of more than one universe. These multiverse are unobservable. They're not universe. They're just outside. Everything we've ever observed is our universe, and the constants are the same. And the claim is, well, there's infinitely many of these other universes out there where the things are different, the constants are different. The whole thing is made up. There's no evidence for anything like that. There's no observation of anything like that. Everything we know, they're constants, and they are the same. And therefore, it's a different type of a theory. Again, I'm not saying that it works out, and there's a lot to go into. And if Anthony Flew is convinced, then again, we're not experts in biology, and that's, their argument might hold up, but it's a totally different type of an argument when you're talking about biology, which emerges over time, and there's many planets out there, as opposed to the laws of nature, which are fixed on the one universe which is observed. Yeah, Aaron, you're going to say something about Penrose?
Oh yeah, I was just going to mention. I mean, it happens to be Penrose is a real scientist, and he doesn't like the multiverse. But I was mentioning the point that it's something for people to realize is we're not arguing with scientists about science. There is consensus among scientists. Almost all scientists believe in fine tuning. It's like it's a fact that if you change these numbers, the universe doesn't work out. That's agreed upon. And the question is not a scientific argument between us and scientists or anybody else. And it's the science is agreed upon. The question is the philosophical interpretation of that. What is the proper inference from the fact of fine tuning? Do you infer that there's an infinite number of unobservable universes with different values of the constants? Or do you infer that there is one intelligent cause who set the constants for the purpose of bringing about our universe? So it's just important to realize that there's fine tuning itself is not really debatable. There's no real argument going on. Is there fine tuning? How much fine tuning? Exact degree of fine tuning? Fine. But essentially that there is these constants that create this tremendous problem. That's something that scientists agree upon. It's what the interpretation of it is the question.
Yeah, it sounds more like they're doing philosophical inductive reasoning to create a naturalistic alternative to a creator. That's often what it sounds like at the end of the day. But I'm curious, what's different about how you present the fine-tuning argument?
That's a good question. It's really important how you formulate the fine-tuning argument. And especially just by hearing us talk right now, a person seems to believe that fine-tuning is the problem. It's all about this fine-tuning. That's the entire problem. And that's not the problem. And if you think about it that way, the argument ends up having holes in it if you think fine-tuning is the problem. The real problem is what Richard Feynman, the famous physicist Richard Feynman, called one of the greatest mysteries in physics. And that is how you explain the constants themselves before fine-tuning. Nothing to do with fine-tuning. Scientists are always trying to explain one level of reality with a deeper explanation. They're looking for a unified theory that explains everything. It's this great quest for a unified theory of everything. And in that quest, they've gotten very close. They've really reduced the laws of nature to the fewest, simplest that they can. Right now, it's general relativity and quantum mechanics. And they're really, at least to a physicist, they're beautiful theories. They're simple, they're elegant, they're coherent. And they would love to unify those even further, to have only one unified theory that explains everything. But they have that, and then they have these 25 numbers. And these 25 numbers, they're just the exact opposite of what they're looking for. They're these random strings of numbers, like, the fine structure constant, 137.039999136 or something like that. And all these numbers, they're just, when you look them up, they're just these bizarre numbers. They seem completely arbitrary. They have no, seems to be no rhyme or reason for them, no deeper way to explain them. And in their quest for the theory of everything, the scientists are looking for the theory that explains the basis of all reality. They end up with one or two beautiful, wonderful, compelling laws of nature, qualitative laws of nature, and 25 numbers, like a list of data. And it's just the complete opposite of what they're looking for. And that leads them to the mystery of the constants. How do you explain a number? Are these numbers fundamental? Are they truly the basis of all reality? Is general relativity, quantum mechanics, and 25 numbers, those are like the basis of all reality? No deeper explanation? And if there is a deeper explanation, how do you explain that number? What kind of theory is going to naturally pop out these exact precise numbers? And if there is a true theory of everything that explains these numbers, it has to explain them down to the last decimal spot, because it's a theory of everything. And that seems to be highly implausible that they're going to find some deeper qualitative explanation that's going to yield these exact numbers, these 25 numbers. That's the mystery of the constants. It has nothing to do with fine-tuning. Fine-tuning was discovered later on. Fine-tuning was something that came later on in the game, and it becomes the clue for the solution. It's not the problem. It's the clue that points to the solution that answers the mystery of the constants.
Yeah, so let me just actually give an analogy to help understand the problem of the mystery of the constants. And again, this is, as Aaron's saying, this is prior to fine-tuning, nothing to do with fine-tuning. It has to do with trying to understand the laws of nature, the cause of the laws of nature, what truly explains everything in our universe. And the analogy is from ethical systems. So imagine you have a society, and a society, many societies have sets of laws. So you may have laws like don't kill, don't steal, don't slander, give charity, don't charge interest, a whole set of laws. And you might have a whole list of tens of laws in this society. And you might try to conceptualize and to simplify and to unify the ethical system in the society. And someone might propose that, I know what, this society is governed by a law that says, do unto others as you want done to yourself. Something like that. And this is a common law, as many people say, like, mocha, that is interpreted by Chazal. So the idea is like, do unto others as you want done to yourself. That's why that explains everything. You can't steal, you can't cheat, you can't, you can't kill. You should give charity. You can't charge interest. And you might have this one qualitative law which would explain all the different laws. And that's kind of an idea like a unified theory, where you have one law or one principle which is responsible for all the other different laws. And that's insight. That's what physicists are trying to do. They're trying to take all the complex phenomenon they see and reduce it to one or as few as possible. And that would be like an example of that law. But now imagine in that society, besides for all these laws, the laws themselves might have constants. They may have numbers to them. So for example, you might have the society has that you have to give charity. Well, how much charity? So imagine in the society, the law was that you have to give 18.37426% of your money to charity. Or let's say you're not allowed to charge interest more than 19.743227%. And the society has, besides for these laws, which are these qualitative laws, they also have these quantities which are built into the laws. Now, if you think about trying to now explain this society and the laws of the society, while before we got to those quantities, it seemed reasonable that this law, do unto others as you want done to yourself, could explain all the qualitative laws. But how in the world are you going to explain those weird numbers? What's do unto others as you want to yourself? Don't make sure you give them 19.87462% charity. It's like, well, how would you explain such a thing? And this is the type of ideas that scientists were trying to explain everything in our universe based upon laws, but these constants were a mystery. And that's what Feynman called the greatest mystery in physics. This explaining these types of numbers. This again has nothing at all to do with fine-tuning. This existed before fine-tuning came along.
So with numbers, this might, forgive me if this is a little too esoteric or beyond the scope of this conversation, but I know you're a numbers guy, and I'm wondering, there's a discussion about whether numbers are real or they're like built into the universe, or they're just sort of like our own mind's projections and our interaction or interfacing with the universe. I'm curious where you stand on this.
Right. Yeah, so I think it's Galileo said that the language of our universe is mathematics, and something to that effect. And it seems like the laws of physics and the success of modern science has shown that the laws are expressed in the language of mathematics and numbers. And that being the case, I'm not sure, there's different ways to ask that question about math and the numbers, but it does seem to be that is the language of our universe, and the Chachmas Hashem, which is evident in the universe, works through numbers. So the third question: do numbers have this pure existence and in like an abstract ontological type of sense, or? But it just seems to be that, at least insofar as physics are concerned, it seems the language in which God wrote our universe is one of numbers.
You don't think God was compelled to follow the numbers, like there are these numbers and God has to obey that? There are people who live, a lot of mathematicians actually believe in this kind of Platonic mathematical universe almost, and
Right.
and there's some people think that's wacky and crazy, but I
don't think God is compelled to do anything, but these are the deep conversations about numbers and all that. But again, I think the numbers are, ultimately God created everything yesh me'ayin, and I don't think numbers predate, anything else. But
I would just add one point though, is there are people who think that way, like it's called mathematical Platonism, like Plato's world of forms, the world of numbers, and people have tried to come at it from that angle to solve this problem. Feynman talks about that. It's people who try to take these numbers and show how they derive from pure mathematics. And there's really, it is a more esoteric point. There's certain things called mathematical constants, special numbers in mathematics that originate, that have nothing to do with the physical world. Like for example, pi, right? The circumference of the ratio, the circumference of a circle to its ratio in Euclidean space is pi, or there's e, the base of natural logarithms, whatever. There's a few of these mathematical constants that have nothing to do with the physical world, that just have to do with pure mathematics. And people try to connect these physical constants, the constants about the rate of expansion of the universe or the mass of an electron, to these mathematical constants and different combinations of them. And it just, they've tried for over 100 years. Feynman at that point was talking about they've tried for over 50 years. Every day every week another paper comes out through different, pi to the fourth power divided by e equals this fine structure constant, different things like that. And then they measure it to one more decimal place, the fine structure constant, one more decimal place, and they realize that didn't work out. And basically, eventually they completely gave up doing that. But that's exactly what you're talking about, Zev, of trying to really derive the constants of nature, of physics, from mathematics. And it's been tried and it's been failed, and basically everybody gave up.
Right. They try to say that, you don't need a God. You can just say, oh, these numbers, these laws somehow exist and then create everything. But yeah, that's a good explanation. It doesn't sound like it can work. So
yeah, that's part of the mystery. That was part of the. If you could have done that, they could have done that, shown how these abstract mathematical constants somehow combine to make physical constants. That would have been some type of explanation. Would have given them an indication. But there isn't. That it just didn't work. It basically became a joke that everybody kept trying and it didn't work out. And that's part of the root of the mystery. How do you explain these numbers that are part of nature that we observe empirically and we measure if you can't explain them theoretically through mathematics?
Fascinating. So I wanted to know what.
Wait, do you want to continue? I'm sorry, and you want to consider, based upon that, that's once again the mystery was the backdrop, the mystery of the constants, and this was a problem which existed prior to discovery of fine tuning. Where do these numbers come from? And then they had this discovery of fine tuning. They realized that although the numbers from the standpoint of physics seem to be just these arbitrary, crazy numbers, 137.137999926, whatever, it was discovered that they're not as arbitrary as they seemed. And if you change those numbers, while it's true, the laws of physics themselves would be the same and nothing would change. But what would those laws of physics result in? And it turns out that that's the discovery of fine tuning, that the laws of physics would change, but you'd never have atoms, you'd never have molecules, you'd never have stars, you'd never have planets, you'd never have life. And that's the discovery, is that the solution or the clue which led towards the solution of this mystery was the discovery. And this is, again, it was discovery. It's in the early 70s, 80s, and 98 was the discovery of this thing called the cosmological constant. They discovered how these numbers weren't as arbitrary as they had thought, let's say at the time of Feynman. They thought they were arbitrary and they could just be anything. And why are they these random numbers? They found their solution. These numbers are not arbitrary. They were specifically the numbers which were needed. The numbers had to be within the small range in order to result in the unfolding to be able to be our universe. And this was a discovery. It was a surprising discovery. And now when you're trying to understand the laws of physics and trying to understand these numbers, you can't just ignore that discovery. You can't just say, oh, I don't like fine tuning. I don't like that. the numbers are that way, having something to do with their resultant universe, which will come from it, let's forget about that. Let's look for some other explanation for the numbers. That's just ignoring the knowledge. Fine-tuning is a knowledge, which was a discovery of which helped shed light on the mystery of the constants. And it would be like going back to our analogy. Yeah, go ahead, Aaron.
Yeah, just before we get to the analogy, we get this question a lot of why isn't this God of the gaps? When people think, well, you're asking this great mystery, how do you explain these constants? People always assume, oh, you're just going to say there's this big mystery. How do you explain these numbers? Scientists can't explain these numbers. They have nothing to do with the mathematical constants. They have nothing to do with any other way of explaining it. A theory of everything can't explain it. So now you're just going to say, okay, God must have done it. That sounds like a God of the gaps. You just have this great mystery. You don't know how to explain it through science. So you're saying God did it. But the point of fine-tuning, that's where fine-tuning comes in. Because like Ellie was just saying, fine-tuning is a type of a knowledge. It's not the mystery. If you just said, I have this big mystery over the constants, and therefore God did it, that is faulty logic. That's God of the gaps reasoning. But at that point, when you just have a mystery, you don't say God did it. You have to first get knowledge of fine-tuning. Fine-tuning is the clue. It's to the solution that God did it, because fine-tuning is scientific knowledge that if these numbers were any different, you don't get atoms and molecules and galaxies. So it's showing you how once you study these numbers and you understand physics, you see that if these numbers were different, that things don't work out in the universe, you start to realize the numbers are not arbitrary. The whole mystery of the constants comes from the fact that you're just assuming these are random strings of numbers, 137.039. How do you explain that? Yeah, but once I see there's a range, and if it was 138, there's no atoms, 136, there's no atoms, now I have a type of an explanation. I could say, yeah, the reason why it's 137 is in order to get atoms. And whoever set these constants had an objective of getting a universe with atoms and molecules and planets and stars and galaxies and life. So that's based upon scientific knowledge. You have an explanation. It's called the teleological explanation. There was a purpose for these constants, and that explains why the constants have their value. That's not God of the gaps reasoning anymore. You're not just saying, I don't know how these constants came from. Maybe God did it. You say, I don't know how these constants came from. I have a mystery. Now I have scientific knowledge of fine-tuning, and that allows me to infer that there's an intelligent cause for the constants.
Brilliant explanation. So you guys have been holding out on us for so many years after the blog. So what happened to the blog, and what did you do after that?
Great question. So I just want to go back to just follow up on Aaron's point, and I'll get to answering your question in a second. So going back to the analogy of the the ethical system. So imagine it were discovered, and again, this is just an analogy to the idea of discovery of fine-tuning, is we had this ethical system. We were trying to explain, how could you explain the percentage of charity, 18.457, whatever percent. Now, let's say that was discovered through rigorous economical calculations, which again, isn't reasonable in economics, but imagine such a thing were possible. Let's say they discovered that if you had the rate of charity would be less than, let's say, 18%, then poor people would rebel and they would end up undermining society because it's not enough money. They're not going to be able to live on it. And if the calculations would show that less than 18% would not lead to a stable society, it would lead to class warfare. And let's say they should also be able to show that, let's say the rate of charity were more than 20%. You say more than 20%, then rich people aren't going to want to work because they say, hey, I might as well be on charity. It's not worth it for me to work. And therefore, that would also undermine the productivity of society. Again, these are just hypotheticals. But the idea of a discovery of fine-tuning would be if you would somehow be able to show rigorously, mathematically, that the rate of charity, which is, let's say, 18.45 whatever percent, it has to be within that small range in order to lead to a stable, productive society. If that were to be discovered, then you'd say, now those numbers aren't as arbitrary as they seemed, but the numbers are based upon their objective, based upon their purpose. These are the numbers which are needed in order to result in a stable, peaceful society. That's analogous to the discovery of fine-tuning. And not just the numbers seem to be arbitrary, but the discovery of fine-tuning showed no, it's not true. Those numbers are the numbers within a range of numbers which are necessary to lead to our universe unfolding.